So we're back on the West Coast with the next edition of the Architects newspaper, All Things Facades live podcast in San Francisco. And our first guest is a glass expert from Viracon. We got Jack joining. So Jack, thanks for coming on.
Thanks for having me on. Happy to be here.
So a huge, I would say, the overall perception of Viracon in the industry is, outstanding reputation, but very innovative, forward-thinking, and technically deep in the sense of a lot of R&D happening behind the scenes, a lot of testing, a lot of innovation. So what would you say are some of those core tenements as a domestic, not only float glass supplier, but IG fabricator that sort of keeps Viracon running and the themes that they try to maintain within the market?
Yeah, absolutely. Just one note. We are not a float glass supplier. So we are actually bringing in float glass from float glass suppliers. The key differentiator with Viracon is that we are the only pre-temperable fabricator in North America. So what that means is we are bringing in raw glass from those float suppliers. We are then heat treating with uncoated glass, right? And then we're adding our low E afterwards. And that's a huge deal for flatness. And that's been a huge deal for a very long time. On the point of innovation, Viracon has had a huge advantage with flatness because of that process, right? And especially with thicker outboards, like 5/16, 3/8. However, for the past couple decades, we have used roller wave measurements to measure distortion, so peak to valley distortion. And that is a really kind of antiquated process, right? That's just a lineal measurement going down the center of the glass. And so when we would talk to architects, hey, you might want to consider 5/16, 3/8. It's going to be flatter. We couldn't really quantify that. And so we have developed a new specification tolerance using millidiopter, which is a much more holistic approach to measuring glass flatness. So rather than just that lineal peak to valley measurement, we're projecting thousands of data points onto the glass surface, measuring it. And it's almost like a topographic glass map, if you will. So stuff like that is what makes Viracon great and cutting edge. We're always trying to push the industry to be better. Right now, our main push is flatter glass. And that's not just for us. We want the industry to go that way. It makes better buildings, right?
So that's very good information. And I'm trying to think of a few angles to push back on to challenge you. So I would say, well, I don't know if you could say flatness is subjective, but flatness is a preference, obviously, where there are other things like life safety or code jurisdictions that push necessities. So on your wish list or your bucket list of wants versus needs, want thicker outer light to get a flatter unit in larger spans, need safety glazing. So need to be tempered or needs to be laminated. One thing I've noticed Viracon, maybe intentionally, you tell me aggressively pushes is heat soaking of tempered glass. Is that a company-wide standard that you believe has been adopted out of measurable data, out of feedback that you've received from the market?
I mean, I can't speak to the data that drove that decision from a leadership level. I can speak anecdotally about my own experience. I've had plenty of jobs where glazer opts out of heat soak on fully tempered units. I get a call out to site. You've got the owner, you've got the GC, you've got the architect, and sure enough, you see that butterfly pattern and it's spontaneous breakage, and it's not just one unit, it's 10 units, and the cost to mobilize a replacement crew is insane. So we wanted to protect our partners. How we did that was by introducing heat soak as a standard with fully tempered glass. So if you get fully tempered glass priced, it automatically includes heat soak, and that's to avoid the situation I just explained. I can't speak to the data that drove that, but I know personally I've dealt with that more times than I can count, and it's tragic every time.
So let me ask this: if, let's say, what you'd recommend to a commercial client, and then also what you'd prefer in your own residence or your own house.
Sure.
Would you first and foremost always recommend laminated for means of safety, or do you think tempered can do the job?
I would just go fully tempered heat soak. Not only is the warranty covering the glass itself if it breaks because of spontaneous breakage, we're covering labor as well. So there's nothing really to worry about. And it's ultimately will be cheaper than an insulated laminated unit.
Do you think this is very application specific in the sense of a shower door might look different than a handrail, that might look different than a storefront area, that might look different than, a terrace or balcony condition?
Yeah, I would say, and this is how when I'm meeting with architects, I always say, you don't want fully tempered glass unless code dictates you need fully tempered glass. Otherwise, always default to heat strength. And I don't care if it's easier to order everything fully tempered. Don't do it. It's more expensive. Save the money if you can.
Okay, so that's on the safety element of it. In terms of flatness, where would you say is the boundary, or the size limits, either height, width, where you start to say, okay, above roughly this square footage, under this design pressure, you're going to want to go with a thicker outer light for overall flatness?
So, and that's really going to be project specific, and it depends on the wind loads, right? So if you've got a really high wind load and a massive piece of glass, aside from aesthetic, you're going to want us to run a glass strength analysis, and we'll do that for you, and we'll tell you if your deflection is over an inch or not, and if it is, well, let's consider something thicker, right?
So do you think that criteria of 1 inch deflection is sort of a strong governing body that we can use for, you're going to test this limit, you might run into problems under that, you should be okay?
Yeah, and it's not necessarily a safety thing, it's a perception thing, right? So if you're an occupant in a building, and if that glass is moving an inch, deflecting an inch, that's horrifying, right? And that's just going to make everybody uncomfortable. I've been taught that, yeah, an inch is kind of the gold standard where you start to really have problems beyond.
So in terms of, what's a project thing that you can think of an example where you convinced the customer to go with a thicker outer light and it really showed in terms of flatness on a larger unitized scale? And you can really point to customers and say, look at this old project portfolio example, and then look at this one, and you can really visually see the difference.
Ooh, offhand, I know there's a couple of them. I might need to circle back with you on that, unfortunately, because I don't want to misspeak and have you flash a project up that looks great, but it's really just 1/4 inch glass. But you probably will.
Yeah.
Just kidding.
All right, so Jack actually thought of perfect project where Firecon was able to execute in a larger scale that flatness using a thicker outer substrate. So tell us about the project.
Yeah, it's Berkeley Commons right here in the Bay Area. It's a 3/8 outboard V&E 63, extremely flat. I drive by it all the time. Every time I do, I kind of pause for a second and go, looks really good. And I always remember it's the 3/8. I couldn't recall it in the moment, but I'm glad I did.
So 3/8, 5/16, just something to consider for flatness instead of that 1/4 light. So Jack, thanks for coming on. What's the best way for people to find Firecon resources on the internet?
Yeah, just firecon.com. We've got a new website I think it's a lot better than the old one. So yeah, hop on there, and we're on LinkedIn as well. Our sales agency is BPA, Bob Paul Architectural. And we're based in SoCal as well as NorCal. Yeah, find us on LinkedIn.
Go on there and you'll see a lot about Firecon. So we have Rebecca on, who just finished your panel presentation from EHDD. So I actually haven't had the pleasure of working with you guys in the past, but it was super informative. So would you say for the most part, a lot of your work is concentrated within this area?
EHDD was founded 80 years ago this year in San Francisco. We're a West Coast-based practice now. We have an office in Seattle as well. The majority of our work is local within the Bay Area region and the West Coast. But as we had presented the AIA headquarters, where there are several types of special projects where our work is throughout the U.S. and internationally.
So a lot of core theme of your presentation and the discussion was around having tools, whether that's around embodied carbon implications or material selection or facade typology that's allowing you to make more informed design decisions. So is this a theme of the firm? Would you say it's a theme of the area? I don't know how much of this is really driven or dictated by local codes versus maybe the clientele that you work with.
Well, it's both. Being on the West Coast, we have stricter code requirements that we're conforming to, but our practice is really based on the impact that we can make through the work. So this early phase design decisioning, really determining the impact that we can and want to make with the projects that we do, is something that's deeply embedded in our practice.
So this is maybe a more off the cuff question, but as I'm thinking, how much of it do you as the architect go in with, like, we have our vision or our wish list or our dream versus it has to match up with the client or the end user and what they see. And, they have to be receptive to a lot of these ideas and invest in this area versus not, and make sure it's worthwhile either to the local geography or, local tenants or whatever that might be. So how do you, I'm sure you have a lot of experiences where maybe it's not the perfect marriage. And is that tough?
Well, we never come into a project with our own priorities that are contradictory to a client's. We have our own values and priorities holistically for the firm about ways that we can make an impact through our work. We have such a diverse range of project types, so each of them may be a little bit different or may have different aspects of them where there's more or less impact to the environment, the community, et cetera. But we always deeply listen and work with our clients to understand what their needs and aspirations are, what their goals are relative to sustainability or their community, and then find ultimately together establish a collective set of goals for the project, kind of working together and coming up with the best way that we as a team can make a greater impact with our project. So it's all about listening and like developing our goals together. It's not about us coming in with a very specific set of goals for this project.
When it comes to facade design and selection, an idea I've been thinking about lately is there's like super technologically advanced design where just more, high performing glazing, more insulation, double skin facade. Like you can get crazy in terms of performance and design elements, but obviously there's the embodied implications. So you flip that and you say, maybe we could look at a little more simple design, on the other element or end of that spectrum. So in essence, we could really push the envelope with performance, but also, it's balancing those operational versus embodied carbon impacts along with the owner's goal. So, everybody likes to throw around buzzwords and talk about sustainable design. What does sustainable design mean to you?
Well, it's going to be specific to the building type, its location, the users of the building. So you'll talk about C-scale a little bit later, but we developed this tool for very early phase analysis where you can kind of explore these bigger buckets that you're talking about to understand in a unique location with all of the details of that site, climate, utility costs, et cetera. Where can we make the greatest impact? Looking at very simple moves and understanding early on how much does the size of the building, to your point earlier, the shape of it, the different types of systems or envelope. We understand very early on what these different moves, how they might inform the overall approach of the building. And it allows us to make decisions early to kind of hone in on a direction early on, knowing that our choices are informed and making the right decisions early on.
And firm-wide, is this somewhat standard practice to take certain measures or use certain tools to help you make those decisions? Is it very much so driven by the client's budget? And how much are you relying on outsourcing a lot of this stuff versus doing it in-house?
Well, this is in-house. We developed the C-scale tool in-house, which was originally called Epic. Now that's publicly available. But these are things that we look at early on. There are a variety of tools that we can use depending on the specific circumstances of a project. There's kind of a set of tools that we use regularly. We'll develop kind of a custom tool if we need to look at something a little bit different for a unique project. But doing this analysis early in the project to know what the impact will be and how we can make a greater impact is something that we explore in every project.
So to kind of wrap it up, what is something you wish you saw more within the design community or architectural community in terms of sharing some of these project case studies or lessons learned on all these projects as you continue to progress? Is this something that you really focus on, continuing education within the firm to share and spread some of those lessons learned?
We do. And I think one thing that's really important to us and that we would want to share with others is just how impactful these types of decisions are early in the design process. For some, sustainability might be a layer that gets addressed later in the design. Once you have your design concept, you've decided on the overall kind of shape, form, and look of a building, and then sustainability might get addressed through various certifications. But for us, really looking at sustainability at the very beginning of a project, we know that's when you can really make the most impact, and that's something that we look at in every project.
So we're going to look into C-scale next with an interesting guest, but Rebecca, thanks for coming on.
Thank you.
All right, we got Brad on, and I'm actually really excited because I came across C-Scale when I was in Seattle a couple months back, and after the panel, there was too many questions, and it was going to bleed into the next session. So I'm really excited, first of all, that we made our way to San Francisco, and it's come up again. But welcome, Brad, and
Thank you.
maybe tell us a little bit about your journey coming from the architectural community into more startup mode.
Absolutely, yeah. It's been quite a journey. So I came from EHDD, an architecture firm, 80-year history, where we developed a tool starting around 2020 to really look at how we could have the biggest climate impact on projects from the very beginning, when you can actually, you still have that opportunity space ahead of you, right? You can decide and help the owner decide, should I reuse a building? Should I build new? Should I use concrete or low carbon concrete or mass timber? What about facades? You know, what would makes the most sense? We built something in-house. We put it out for free on our website. We got tons of interest, thousands of users, companies coming and paying for our data models. We spun out about a year ago, raised some money, and now we have a software company. I'm co-founder with Jack Rusk, who was with me at EHDD. We're now working with about 200 architecture and engineering firms across North America, and as well as a number of building product manufacturers.
It's amazing. The first thing that came to mind when you were speaking is the opportunity, I think, to do this type of assessment on an existing building, particularly, you know, I'm from New York, and you can't believe the amount of office conversions that are ongoing right now. Do you see that as a good sort of project avatar for this type of application?
Absolutely, because, you know, I mean, the best thing you can do from an embodied carbon standpoint is not build new if an existing building will work for the uses that you have intended. And what C-Scale allows you to do is, like, we know that intuitively. I mean, anyone can kind of understands that. You can actually measure it quickly, and you can, with a slider, say, well, what if I saved half of the facade or 25%, or and you start to see the numbers change. Or even within an assembly, an existing assembly, like, okay, let's say we replace the outside cladding, but leave the inside wall. You can actually get down to that level to really fine tune your level of reuse and see the numbers change.
So how much do you think this type of software is going to expose a lot of presumptions that may or may not have been, you know, falsely assumed or accurate? And do you think this could, in time, influence progression of codes?
We hope so. That's certainly one of our kind of impact goals. I think it does. I'm not sure if I said this initially, but the kind of big move of the software is that we put together, it's called a whole life carbon assessment. So you look at operational carbon, so the carbon that comes from actually using energy throughout the life of the building, with the embodied carbon, both the upfront embodied carbon, like what it takes to build it day one, as well as the turnover in interiors or replacement of facades over, let's say, 30 or 60 years. So when you look at all that, some assumptions around what really matters if climate is your actual goal, it can be surprising, and it can vary by location, right? In a place with a clean electricity grid, like where we are today, San Francisco, electrification is a huge driver. Just electrifying really changes your whole profile. Some other states right now, maybe not as much. And then understanding that how big embodied carbon is, especially in a place like San Francisco. If you electrify the building and make it code compliant, your emissions around energy are very low. It's all comes from materials and systems that you choose to build with. So I think that's where I think it might start to change policy, is thinking if policy's goal is to impact climate, I think it'll start to shift more towards embodied carbon.
It's interesting. It's one area, energy source, that I think most people overlook. But another one is, I wonder what, in terms of material procurement, how much does transportation play into this formula, especially if you're sourcing material from other parts of the world?
This is an area where, I mean, it does matter. And when you look at the whole picture, usually it's a relatively small component, because what's hard to really comprehend is the amount of raw energy that it takes to mine and then especially fabricate materials. It's a whole other scale level than transportation, especially when you're transporting things from across the world. It's mostly on boat, which is actually quite efficient. So it's a complex. I'm not going to say it doesn't matter. And if it's a low carbon material, transportation matters relatively. But if you're, smelting metals, and then if you're using concrete, which has its own chemical reactions that release CO2, It's a scale difference.
Where I come from, or in the Northeast, you have a lot of local codes that are now putting thresholds or benchmarks around, call it overall. I'm trying to simplify or dumb it down so people can understand just carbon output.
Yeah.
So how much, as you said, it takes to operate the building on a yearly basis. You could look at utility bills and so forth and measure how well does this building actually perform. So it really is performance based. You forget the design criteria. What matters? It's the output.
Totally.
Can you see a day where embodied carbon implications drive and impact project decisions from a code standpoint?
Absolutely. So I think maybe one example of what you're talking about, like Local Law 97 in New York, right, which really does regulate the operational emissions, which are only known after the building's built, and only known and can change. So like an energy model is only so helpful. It is helpful, but it doesn't actually tell the story. The embodied carbon is actually easier once you actually have your contract documents. There'll be changes. Okay, that carpet wasn't available. We use this carpet, and that can matter. But it starts to become more clear. You're really baking in the trajectory of the carbon. So in terms of codes, when you have out here, California, Cal Green, or the California Air Resources Board is now trying to implement policy from the state level to really drive low carbon construction. Buy clean programs, which just require EPDs on certain materials. Boston's and Massachusetts are far ahead. So there's a lot of municipalities and states that are starting to either bottom up from cities, requiring life cycle assessment, or top down at a state level. There's some climate policy, which then directs state agencies to figure out, okay, how do we then enact this on the ground? Like, what are the requirements that we need for buildings at the permit level that would support this policy? So there's a lot of New York State actually has a state directive that's like in the works. So it's going to take a little while in most places to filter from policy to code and then back into the permits that are being issued.
Are you getting activity overseas or internationally rather with the software?
So a lot of, as we work with about 200 firms right now, and many of them work overseas. So our data sets are spotty overseas, but they do in the Middle East and Singapore and England. There's certain countries that are well represented. But if you're primarily working overseas, there's just a lot of data gaps. It's not even the fact of like us not having the data. Partly that, but also there's just a very kind of Wild West in terms of harmonizing data and the data quality and the gaps that exist in different parts of building material.
So just focusing on North America, I'd say on a final note, what is your wish list? What do you want to see happen? I mean, do you want this to be accessible to everybody? Do you think it can be accessible to everybody? Do you think this is way above everybody's head, where it's way far out that this is standard practice?
It's a great question.
What do you want to see in the short and medium term?
Absolutely. I mean, our North Star goal is that every project, on every team, every project is doing some amount of carbon assessment to inform decisions. And so that's what we're focused on, is making it really accessible. Because when you think about climate and the scale of change we need in the built environment, it's great to have those exceptional projects. We always need those to point the way, but we're never going to get there unless every project is figuring this out. So we're mostly a bunch of architects and others, software engineers, but we're really using design to make it accessible to designers, make them not feel like they enter it and say, oh, this isn't for me, this is for like the carbon geeks. That we want it to be fun, engaging, accessible, low cost, so that firms can really make it a standard practice that every project, maybe they just do a little bit of it, and then some projects take it further with the platform. But really meeting you where you are is our goal.
It's great because we just spoke with the EHDD, and I think that's become standard practice in their firm. So it's like once they adopt it, it's just going to ripple throughout.
Exactly.
Thanks for coming on. This was super informative and excited to hear about more. All right, we have James and Karen joining us, and we just finished a panel where we got to see a beautiful commercial project you guys just finished with one of my favorite clients, actually Longfellow, who does work coast to coast. So I want to dig into the technical questions on the project, but first of all, thank you both for joining.
Pleasure to be here. Thank you.
So what was super interesting is the project actually went to a mega panelized type of solution, but that's not actually where the design concept or criteria stemmed from. And you talked about the decision criteria around going with a rain screen versus barrier system. Can you speak a little bit to the early stages of the design concept and what you were thinking when you were marrying those opaque and vision elements?
Sure, yeah, I can start talking about it. When we first started working with the client about how to develop this design, it started with the constraints of the train, the airplane, the vehicular circulation around the site, and we would talk about transit-oriented development. So a lot of the design decisions started with understanding what are those constraints. And the biggest one was noise. So we started to think about ways that we could both mitigate noise with a thicker, deeper facade, but also respond to the client's desire to have floor-to-ceiling glass, and then establish a few very simple design criteria, which kind of helped the design team and the engineering team work through some of those details when we started to go in and out and create depth. So in the end, they wanted to see out all the way up to the top, and they also wanted to create more usable area and kind of like stand inside the facade. So it was kind of a combination of usable area, creating more space for their tenants, in conjunction with kind of understanding what was happening outside and try to turn some of those constraints into opportunities.
In terms of, so Karen, I'm going to go to you on the performance element. You want better acoustics in an IGU. You can manipulate the airspace, the thickness of the outer inner light, put in lamy. But in terms of those opaque elements, going with a deeper facade, the system was GFRC. So although you get that depth and articulation, it is very lightweight. And I'm not sure if everybody understands how that all comes together. So what type of acoustic performance can you expect in that type of system? Is it on the higher end?
Yeah, I think there's spray foam insulation on the inboard face of the GFRC panel. So that's enhancing the performance. The GFRC is relatively thin, it's less than 2 inches for the most part, but the insulation is providing additional performance. So then it was looking at the glass and aluminum as the weak points and ensuring that they would be able to sufficiently hit the criteria of about 42 STC, 43 in some areas, I think. And so that was the performance that was achieved. There's a little, like 1 dB higher for where there was a special acoustic interlayer that was used.
So if you look, I don't want to get too into the weeds about acoustics, but if you look at, center of glass vision area, center of opaque area, I don't know how else to say that, what becomes the weak point? Is it your interfaces?
Yes, it's always the joinery, right? Wherever you think that air can travel through or a material can resonate where you don't have don't essentially have mass there. So, but at sealant joints and things like that, it's continuously sealed and we know that we're not going to have any air gaps. So the concern was always at the fenestration itself, at the joints between glass and aluminum, would there be some leakiness essentially to the system? Because the windows are constructed as these mostly all glass corner boxes. There's a mullion in there, and those are the areas that were more heavily scrutinized for acoustic performance.
And I did notice in the section details that they did 2 lines of sealant. I think both were applied from the exterior. You had sealant back rod. And I know in California, that's not always the decision that's made. So most people think about air and water infiltration and the ability to resist. And in that case, you have to have a perfect perimeter seal. So was that something that you had to upsell the client on? Was that the expectation from day one?
It was the expectation from day one. I mean, I think if you embedded in the specifications that is the nature of the system, then you're already in a better place to be able to defend it in case there's some argument against having 2 lines of defense. I think there are areas that are quite complicated and where the GFRC scope and the glazing scope, fenestration scope between Coalition and Willis is complicated and required a level of trust between the 2 partners, also using the same sealant contractor to do the work in the field. They're both engaging the same second party or third party contractor to do the sealant work, so it can all be done in one go. Even though the stack joint, for instance, those 2 lines of those 2 seals, they are crossing from GFRC to GFRC to Coalition's glass and aluminum. So you've got those 2 lines of sealant that are bridging 2 different trades. If you don't have the ability for those trade partners to work together, to really look at each other's drawings, to coordinate, then those seals are always going to be challenging. The corner window units are totally orthogonal.
and they are nested behind the curved GFRC panels. So there is a portion of Coalition's window unit that's buried behind the GFRC, and the sealant line is tracking across an opaque panel. That you can, in order to do that detail, there has to really be a level of coordination and trust in the parties between, and I should mention level 10, the general contractor was also facilitating all this and making it possible.
Well, that's what I was going to ask about next. This is you're specifying, you're designing, you're trying to achieve this superior level or premium level of performance. That's all well and good on paper and in specifications, but when it comes time to selecting subcontractors and then getting them to play nice together is not easy, because I've seen this done from New York to Canada, where Florida, you could pick this precaster, pick this glazing contractor. Doesn't mean they're going to get along well, and it doesn't mean everything's going to look pretty behind the scenes. So what level of involvement did you guys have beyond early construction phase during actual CA?
Well, as the architects, we were involved throughout the entire CA process. And I think with Heinges and our team together, there was also a level of discussion in terms of how we would manage the specifications and how those were implemented. And of course, levels of interpretation between all of the way things were written and actually employed. So we were involved very early on in the process and developed a kind of a series of a coordinated, not always polite, but coordinated sessions between all of these different stakeholders to determine kind of what's the best path. And it really did come back to the specifications and how they were written and building in a level of detail which we could all work within. And the specifications were actually much more robust. And we had kind of what I would describe a combination of traditional specifications and more wall system specifications. And so to me, what worked well is the kind of dance between those two types. It allowed both parties, I think, to engage in a way, but also held a line on waterproofing, for example, or levels of interaction between some of the components and finishes and those kinds of things.
When it comes to what you draw and what you specify versus putting a level of practicality or realism into how it will perform, you go to all different parts of the country, and this is what I like about the show, the conference, we get to hear from all markets. And you go to certain markets, barrier systems are business as usual. You go to others, they only do pressure equalized or rain screen cladding systems. So did expectations shift when you decided to go the route of a barrier system? And if they did or did not, what level of either quality control or quality assurance did you implement to ensure you would get that level of performance?
When the transition to thinking of the GFRC as a barrier system and not as a rain screen, with a window wall unit behind it, then the GFRC had to perform as a completely watertight system. And it was subjected to all the typical curtain wall tests, the AMA tests, the same testing that we did for the windows and fenestration. And it had to perform essentially flawlessly for it to have that level of confidence and not have to rely on the spray foam behind as as the backup, system for water. So I think that was part of getting a comfort level of using the GFRC as that barrier system. And I think that was, and that might not be possible in a more thermally demanding climate. There may be different considerations, but it certainly worked. And there was no issue at all with testing the GFRC to 15 PSF for water infiltration and air infiltration.
Yeah. Yep, absolutely. And I think for us, we learned from a previous project using GFRC about form design and how the formwork plays a kind of a very integral part in how these barrier systems work. And so in the conference, we showed this image of this large mega panel form and understanding how all that concrete comes together and how that works as a barrier system, and then how the forms are ultimately built, I think played a really important role in how we understood the geometry and then how that geometry works as a barrier system instead of a rain screen. Because again, subjecting it to all those details and all the testing kind of proved this out, that we could use GFRC as a barrier system.
Especially in this type of level of complexity, customization, performance, when you're dealing with atypical conditions and corner units and nested frames and maybe concealed sealant joints and so forth. How do you think about serviceability, maintenance, being able to replace components, glass replacement, maybe it's an exterior glaze system, making sure the sealant joints are accessible. So, even though the opaque area might stand the test of time and your structural elements of glazing might stand the test of time, you could replace those components in 20, 30, 40 years. So was the durability element of things considered early on?
Yeah, I mean, I think the size of the building makes it manageable. It's different when you think about having to access exterior sealant joints on a very tall tower. So I think that there's also kind of just the building itself makes it reasonable to think that if a sealant joint did need to be replaced after a certain amount of time, that it's not too intensive of an effort. But yes, the window units, I mean, obviously those can be replaced. I mean, they're installed into the mega panels at Willis's facility, so they can be, taken out and reinstalled again, and they're manageable discrete units. I think one of the other interesting aspects of the mega panel system is, I think there maybe is sometimes a conception or misconception that the frame of this is something that I learned on the project, is that the mega panel frame needs to be almost like in a plane of itself, and that it needs to be planar. I guess and the mega panel frame in this project it has almost like vertical buttresses in a way that take the dead load and land on the top of the slab, but then the horizontal, there's vertical structural members that are taking the load of the panel, and those are behind the opaque GFRC areas. But then there has to be something horizontal that ties the whole panel together. And it couldn't be at the floor slab level, directly above the floor slab, because these window units want to be ones that someone can step into and get very close to the glass. So we couldn't have a big, deep sill, which you see on a lot of projects. It's nested up at the head, so there's a truss at the head of the mega panel, which is either tight to the ceiling or hidden behind a very deep beam at some of the structural connections. And that, I guess, lack of planarity of the steel frame at its inboard plane allows that in and out of the windows to occur, and was really some very creative engineering on Willis's part to make this happen.
Is it sort of like a Canadian style hybrid system, bypass system, in which it might look like a curtain wall, it's outbound of the slab, but you're able, in that case, you set it from the interior and your connections are set from the inside, but it does sound like what you're describing, the steel connections, but you have some elements that are inboard of the slab and some elements that are outboard.
That's right. It nests kind of in front, and the stack joining is at the underside of the slab. But I think it allowed that flexibility of the frame design, allowed the design, the push-pull essentially of the windows and the GFRC to really occur.
Yeah, I would describe it like a chassis of a car, and that chassis was the strongest part of the chassis was at the top, and then this thinner part of the chassis was at the bottom. But the chassis is basically the cantilevering out over the slab, which allowed the slab to come inboard. And then that's what when Karen's referring to this kind of step-in portion, it allowed that kind of creative, more angled truss of that chassis to come in and be kind of floating above or basically outboard of the slab.
I have so many questions.
Yeah.
Two more questions.
Sure.
Just because we could keep going on about this, how much were you reliant or dependent on a very high quality slab or placement of your embeds? Because what you're describing relies on system within certain tolerance of your structural connections or connections back to the structure.
Yeah, I'm thinking how we answer this. It's the push-pull connections which are being tracked and monitored. And I guess initially in the initial phase for the curtain wall portion, we provided a wireframe to Willis, or not Willis, actually both parties, Enclose and Coalition, to determine where their embeds would be for the curtain wall portion. And then with Willis, we also used a 3D model, and their engineering team was working on the push-pull connections for the GFRC panels. And then level 10 was tracking the pores and understanding the tolerances, because they had ultimate responsibility for the install. So they were hyper aware of the timing, the placement, I think ultimately the location of the push-pull connections and the standard connections for the curtain wall. So in terms of how it tracked, that's their means and methods, and they had a pretty exhaustive way to determine it, but that's what I'll say.
Yeah, I think with the feature of the mega panel system is that it translates with the slab. So those panels sit on the slab below, unlike a curtain wall, which is hung, and they translate with it. They don't tip or rock, they're rigid. And the only place where the seismic movement needs to be accommodated is at the corner, because you've got those two panels moving relative to each other. So I think that also had some advantages with the walk-in window, because with a curtain wall unit and interior finishes that get very close to it, there's always the vertical differential movement challenge of, okay, the curtain wall panel is hung from the floor above, but yet all of my interior millwork and finishes are base loaded. So where does the movement, joint happen in between? With an advantage of this kind of system, which is base loaded, is that it moves together with the floor you're on. And I think that will be an advantage ultimately for the tenant.
On a final note, it seems, or what I've seen is that you guys have successfully completed a handful of these projects, whether it's in healthcare or office buildings, where you utilize high window to wall ratio, maybe in a mega panel style fashion, a lot of articulation and depth. People seem to love it out here. It seems to be championed, and I mean, the architecture is gorgeous. I don't see a lot of it where I'm from. So what have you learned from all of it? Is there a theme around all of this? And do you think you're going to continue to see more and more of it?
I mean, I think for us, as an architecture firm, learning from it is, I think what Karen brought up in our presentation is learning to use the material for what it's really good for. A lot of the people on our teams with our clients have used aluminum and glass systems pretty extensively, but GFRC, in order for having horizontal pronouncements or even sculptural pronouncements, we've learned the limitations for that, but also the benefits, right? And learning how to use material for what it's best for, which has all sorts of benefits down the line with the engineering teams and ultimately the clients that are using the buildings.
It's interesting, the window wall ratio on the project is actually pretty low.
It's 35% for those of you who are
Yeah.
interested.
It's
35%.
surprising, right?
Yeah,
You
surprising.
look at the building and you think,
Yeah.
oh, it's got to be somewhere 40
Right.
upwards.
No, it's 35%. I looked at the energy model and I was like, wow, that's incredible. But we had to, because it's an all electric building, we had to get our loads down pretty low to make the numbers work. So that's why we had that kind of flex in the windows sizing, so we could kind of tune it, if you will. And
So when I see all these people battling for the window to wall ratio and, we need more glass, I'm going to flash this in front of them so you can make something sub 40
Yeah.
look pretty damn good.
absolutely.
So thanks for joining, guys. This is a lot of fun.
Pleasure.
So we got Phillip on from Kingspan. Phillip, welcome. And
Thanks for having me.
everybody upstairs has seen Kingspan, but for everybody down here, tell us a little bit about what you do.
Yeah, so National Sales Director for Kingspan Benchmark. Kingspan does insulated metal panels, but originate from Ireland. And so we have multiple different companies underneath our wing. So Tate Flooring, Morin's upstairs. So Kingspan, Morin by Kingspan. We also have All Weather insulated panels that is also here too. So Kingspan has done a great job of diversifying the exterior facades of the company. And so we have many bites of the apple, if you will. So my particular position is nationally running the architectural side. So on the architectural side, we focus on custom modules, right? Radius on corners, double transverse bends, double longitudinal bends for all the fancy names. But we do modules anywhere from 12-inch wide all the way up to 42-inch wide, whereas your standard in the industry is going to be 24, 30, 36, and 40. So we can customize throughout, which is great. Our facility in Columbus, it's a manual process, a lot of labor involved, a lot of fabrication involved. These guys are artists with the panels, and it's fun to watch us working with architects and getting them specified, and those guys making what we got specified and designed with them, and going up and seeing it done by hand is pretty cool.
I'm somewhat new to the metal panel side of things in that can't speak to what you just said about what's custom versus typical in terms of modules. Understand the means and methods of glazing it into a curtain wall or window system, or applying it to a rain screen assembly on a tracker. What you just said, if somebody just has a standard 2-foot by 4-foot metal panel, does that not really sit in your wheelhouse? You're looking more so they're looking for shape and articulation and geometry.
Yeah, we can. So typically in the past, flat smooth was considered architectural, but now we call it, there's a gentleman on my team, Doug, who used the analogy, we're giving a box of crayons to an architect, right? So whatever their mind draws and puts together, make your mark with benchmark. That's what we say, right? So if they want to see a transition from multiple colors and different sizes where it kind of looks like a checkerboard, or it looks like it's protruding away, they can do different things with the modules, right? And then going around a corner, they want a seamless transition. Well, for the non-architectural piece of it, for the panels, there's trim that's put in, and sometimes exposed pop rivets and things like that. And a lot of times in the design community, I don't want to see any fasteners. I don't want to see anything exposed. And so that's where the architectural piece comes in, and we can design and we can form these corners and trim pieces that nothing is exposed. We use extrusions to hold the panels on for the base. We do stack extrusions if we're going on top of another one. So there's a lot of things that we can do and customize to fit what they want to kind of hit their design intent. That's really what we're doing. I try to tell my team, like, the way we approach it is, I'm not trying to sell you something. I'm trying to accomplish your design intent. So if you want to get there, we just did a job in Alaska that has 62 different module sizes. And so a module is, it could be a 12-inch wide by 24-inch tall or long. It can be 13 and a half by 24, and there's 62 different sizes of these, right? So it kind of throws a curveball at you, but that's what Benchmark can do from a customization standpoint.
Is it limited to extrusion presses that you have?
No.
How does your engineering team think about somebody comes and says, we want to push the boundary and go larger?
Yeah, so the one thing that we have to be careful of in metal is not all of the bare metal is going to be perfect, right? So when you see steel being rolled into coils and so on and so forth, you're going to see imperfections. So when it comes to architectural products, you don't want to go too big, too wide, too dark of a color. If you go too dark, you run into oil canning issues, seeing the imperfections of the steel.
So you don't want to go too wide or big without stiffening.
That's correct. Well, even if you did stiffen, because of the imperfections of the steel, you can see it. So what you want to do is you can control that a little bit by going smaller modules, shorter panels. So let's say black, for instance. If you want to go with a black panel, we try to limit that to 12 foot, because what we've found in the past is any panel that we made over 12 foot in length, oil canning tended to be an issue, right? And it's not necessarily something that if we're sitting here in this room and we see the panel, that it's going to show it. But at certain times of the day, right, when the light's fading, sunlight's fading, or in the middle of the day when it comes around this other building and hits it, right, you'll see some of the imperfections. So that's what we have to be mindful of.
And how does that process look in terms of expectation management, especially early on, doing full-size visual mock-ups? And even if they do see a mock-up, as you just said, certain exterior conditions, but also under certain design pressures, higher up on a building or extreme corner zones, and that stuff comes up and they say, Phil, what the hell? This isn't what you sold me.
Yeah, so that's a great question, because that's one of the things that we try to catch up front, right? If we're in there in the design phase early on, we can caution them with some of these things, right? IMPs have been around for a while, but they're not as widespread as your traditional built-up wall or your tilt wall or so on and so forth, right? Concrete's king right now. So we're trying to change that one building at a time with IMPs, but it's about the education process. Architects, extremely smart individuals, really great with design, but there's new products coming out on a regular basis. And so we got to stay out in front and educating them of the capabilities and some of the solar reflectivity, what that looks like on certain colors, and just keeping them educated on that process so they know what to look for when it comes to that.
So without downselling other materials, how do you combat some misconceptions or theories that go around in the industry that aluminum's a very carbon intensive material, or that aluminum's not a very sustainable material? I come from the aluminum fenestration background for a long time, so you hear that left and right.
Yeah, so we're steel, not aluminum on our side, but our quad core foam is 28% more sustainable than any other foam that's out there. And if you look at our planet passionate focus as a company, we do a lot of things. May not be in our product that you see it for the bare materials, but it's in what we do. So when I say that is we harvest rainwater at our plants, right? So we have several tanks at our plant in DeLand. We're adding some to our plant in Modesto to collect rainwater, so we're not pulling from the city for anything other than drinking water. We have solar panels on each of our manufacturing facilities that we own. Our goal is to have zero waste to landfill by 2030. That's a pretty big goal when you talk about where we have steel and we have foam that go in it. So one of the cool things that we do that I think we talked about this at Green Build was any of the foam that comes out of our panel on the manufacturing process. So any of the waste, right? Post-industrial, so you're picking it back up and putting it back in. However, what we do is we will ground it down to like a sludge in a machine that we have in our facility. And then we sell that to a company called Beltertech. And they have sold it to most recently a paver manufacturer out of Miami. And they've mixed seashells from the beach plus our sludge. And they've taken some weight out of their architectural pavers. It's added obviously recycled content to their architectural pavers. And so we're finding ways that we're not sending anything to the dump. We do a ton of things with the environment and all over. It's not just US. I mean, in Europe, we're doing it. In Asia, we're doing it. We're trying to be mindful of the world we live in. So when we say planet passionate, We're planet passionate, we're people passionate, we care about the environment, we care about what's going into our materials, and we care about the people that are installing them as well, right? So it's sustainability for us, circularity. We've gone a little bit further. We're pioneers in the industry when it comes to that. We've done some things, the cradle to grave, cradle to cradle, right? We've done some things that other manufacturing hasn't done that are embodied carbon. All these things that are buzzwords now. We've been working on for the last 5 to 10 years.
And it's probably, there is a huge, I would think, opportunity to work with someone like C-Scale to, especially on the material side, as we were discussing earlier in the podcast, to sit there and help bridge material suppliers to architects to make better informed decisions.
Absolutely. I think it's about education, right? And so we're educating from an install standpoint with our customers. We're educating to the architect when we're doing our lunch and learns, or when we're doing our meetings with them. When we go to Green Build, right? When we come to Facades Plus, these are where we get an opportunity to talk about the goals that we have as a company and how they can reach their goals as a designer or as the customer's intent behind their building. Hey, I want this to be, a sustainable building. I want this to be LEED certified X, whatever they want, and giving them the tools for us to be able to meet those goals. That's what we want. To go back to what I was saying, I don't want to sell you something, right? I want to help hit that design intent. I want to be consultative with you so that we're hitting the same goals. Because if I win a project with you and this gorgeous building goes up, well, that's an advertisement for me every time somebody drives past it, right? But I want you to come back to me for the next building. I want you to come back to me for the next building. If I sell you something that is not sustainably mindful, which is what you told me in the beginning as a designer, if it's not accomplishing the design intent of what you're building, of what you're trying to put together, chances of you coming back to me in the future to help you design assist in the future are slim to none, right? So it's about walking the walk, talking the talk, but also being truthful with it and what your product does and can do, and being upfront with all those potential imperfections that could show if the design doesn't take that into account.
I like it. Phil, thanks for coming on.
Yeah, man.
Conversation.
Thanks for grabbing me.
So we got a glass expert on the podcast. Felix, thanks for joining.
Hello.
So we see, I've asked this before, there's a lot of newer glass technologies, maybe not new, things that have been studied along the way, things like we were just talking about, skinny triples, FIG, even I could throw dynamic glazing in there, but that's sort of in a separate bucket. As an envelope specialist and a glass specialist in particular, how do you guide your clients when there's maybe limited testing data around something like this, and B, limited forms of how an architect can specify a product like that? In a world where architects will be very quick and you need some form of rinse and repeat specs with slight tweaks. Now we're talking about a whole new universe. So, what are some inherent challenges that come up with introducing a product like that on a project that's looking to push the envelope?
So typically it's not the entire product, right? The glass unit is made out of series components, right? There's an edge seal, that's the primary seal, and some spacer, or like a homogeneous, like hot melt that you see now, or and then there's a structural edge seal, and then there's glass panels that are heat treated or otherwise treated to some extent, and then there's a coating, right? And so all of these components have different service lives, right? And you can always trace it in a way back to taking apart what are all the different components we're talking to, right? And what's the durability of each of the components of that unit that we want to see, right? So in the end, you can, even though there's something they claim is totally new, most of that will already have been in service for quite a while, right? So what I would get nervous, for example, is if there's a new coating, and that used to be an issue, for example, when the triple silvers came out and you were getting triple silvers from suppliers from, say, Asia, and they didn't have a lot of track record. They often were still fine-tuning the recipes, and units that we were post-ordering had different colors. So those are things you would want to see at least. For me, I would be safe with like a 10-year track record or something, right? But then there's other components like different novel spacer technologies also, where parts of that have already been around, right? And so you can kind of extrapolate from what's there to what you can buy now and see how this has performed, right? And especially warm edge spacers, there have been failures in the past. People have learned from that, and therefore the newer products are better, right, and more known. And people have learned from those early stage failures.
Do you think, in looking at just a typical 6 mil, 1 inch IGU, half inch spacer, just I don't know, tempered light, one low E coating, warm edge spacer. Do you think we've really pushed the limit in terms of how far we can go with that IGU makeup or construction? You're just talking about coatings. Is there still room for improvement, or are we at the point where we're at diminishing returns?
Well, it still depends on who's supplying it. And so, there's, if it's tempered, I would typically try to, obviously, as much as we can, go to heat strength, and if it's not having to be safety glass, right, to just reduce the amount of nickel sulfide breakages, right? And so if you go fully tempered and it's a large project, I would still recommend doing heat soaking, right? And so not every supplier can do that. So even there, they still have a lag in a way for especially smaller suppliers. And then there's the overall thing of durability, right? So I know that we're getting 10 to 12 years typically warranty. JF earlier mentioned he could get to 20, but I see typically around 12 being offered. And that means the glass is expected to last maybe 25, maybe 30 years on a project. In theory, right? If you look at projects from the 80s, or I've been working on refurbishments of projects from the 70s, right, mid 70s, they're old as me, and the glass was still in place, and it didn't have soft coatings, and it didn't have spaces with desiccant, and that glass lasted a lot longer, right? So I'm somewhat thinking, why can we get not that? And with the technology that we have, we should be able to expect that level of life expectancy, even from a typical IGU, right? It's just the amount of sealant, the amount of quality of the edge deletion and the edge seal, and the amount of desiccant that makes up for any moisture leaks that go into the unit.
So why those units from the 70s and 80s that are still surviving around the building? What was the construction? Is it just
they were just single glazed, right? And so they didn't have that issue, right?
So that leads to the question: do we need to go in the direction of reverse engineering and going backwards from the concept of an IGU? And the first thing that's going to come up obviously is VIG, which in a way it's not an IGU, but you still have a hermetic sealer on the perimeter that needs to be addressed. So, are there discussions or thoughts around trying to reverse and go in the other direction instead of just add another light of glass? All of a sudden you have a triple laminated unit, you have 4 pieces of glass in that. Think about the weight of an assembly in that sense. So we're pushing too far where we need to tread back in the other direction.
So I think the problem becomes the way that the material, so glass is a very durable material. As soon as you go to polymers, right, you start adding a material that has a somewhat shorter service life, right? And we know that silicon in theory can last 50 years. We know that butyls in theory should be, but still it's probably the quality of the fabrication and the way that it moves over the time that those materials, as this full assembly, don't make it. We were a long time ago discussing that when I was still in London, my old boss and I, about, can we make an IGU that lasts forever? And rather than basically sealing it and making a finite project by sealing a certain amount of desiccant into the unit, to create it somewhat in a method that you can redesiccate it, right? And so the problem becomes that it was proving very difficult to find products. We were looking at moisture pumps, membranes that transfer moisture from one side to the other under an electric charge. They were not able to maintain a dryness that you would need to get the silver coating to survive. So you would have to go to a very different coating technology that's more durable, maybe, but doesn't have the performance, right? So you're always in this level of performance versus the carbon or the energy you're spending on the product, in a way.
So we might be talking basics,
Yeah.
In your language, but explain to people the purpose of desiccant to dry out that airspace, but understanding that some moisture will get in. So when you get IGU failure, it's not that, all of a sudden now you're getting moisture ingress. It's that you don't have anything to fight against it anymore.
So the thing is, so the unit gets basically sealed in the factory at a certain condition, right? And so whatever the spacer technology is, that spacer contains a certain amount of desiccant, and it's finite, right? So whatever you put either in the spacer product or in the liquid applied spacer that's printed on, and that desiccant will pull the moisture out of the cavity, but over the time there will always be small amounts of moisture leaking into the unit through the edge seal, because none of the materials that we are using are 100% moisture tight, right? Butyl still has a very high resistance to moisture transfer, but it's still not tight. And so over the time, that amount of moisture that comes through that edge seal will use up that desiccant that's in the unit, to a point that at some point, you have the desiccant is saturated. And then what you typically then see when you have a very cold day is that you see the units fogging up, right? So
where is that moisture coming through?
it's just coming through the edge seal.
So it
Yeah.
goes, it bypasses the secondary seal and the primary seal.
Well, the primary seal basically is the vapor holding element. And yeah, over the long term, 20, 30 years, and they just let very slowly some moisture in until a point that the unit's desiccant is used up, the desiccant. And so the more moisture you have, that's why it's important, right? To ventilate well and keep any water right out from standing on the edges of the units in the glazing systems. That's also a reason why I say overhead glass lasts typically shorter than vertical glass, right? Because there's a much higher chance that water will come, sit around the unit, and then be able to go in. It's not draining out as well, right?
Let's play devil's advocate and look at, because I gotta be honest here, we do a lot of these conferences in climate zones or markets that are very, very heat-dominated climates, but very progressive energy codes.
Yeah.
You go to San Diego or Florida, you might not need an insulated unit.
No.
So what happens now? I mean, I'd be curious to see how long these glass units are lasting in a commercial, Florida high-rise bunch window building that's only using a laminated piece of glass, not insulated.
Well, the laminate has a life expectancy too, but I mean, I would say a typical IGU can last easily 30 years. And I think the technology should be there that you could make it last longer, like 50. There's a question of how long the rest of the building will be surviving and at what point the design becomes in a way obsolete, or there's an interest for comfort or other reasons to refurbish the building. But in theory, like the materials and the technology is there to just make them longer. It's just nobody does it because everyone is just working towards those 12-year warranties.
If you have a coating, so a substrate with the coating on top make contact with an inner layer,
you can. There has been projects to, when you edge delete it, and with certain coatings that have low silver content, you can just use the interlayer to basically keep the coating dry. But what you're losing is the low E effect, right? So normally the coating in an IGU has two effects. One is to reflect energy out. The second is the heat. It also reduces the low E effect, reduces the heat radiation inwards or outwards, right? So that effect goes lost when you're putting it in a laminate, right? You're down to like a U value of say 1 for just the plain like laminated glass panel compared to like say a 0.25 or so for an argon.
I'm just wondering, a monolithic laminated unit with a coating on number 2 and 3.
Yeah.
If that would make sense and how much performance you could really get out of that.
Well, we've played around with it, and there's somewhat like a threshold when you don't want it to get too dark. So we looked at it for a skylight for renovation here in San Francisco. And there's a threshold of like in the region of 0.3 or 0.25, 0.3 solar heat gain coefficient. And it gets at that point really dark. So most architects, I think, would at some point see that glass and say, not really what I want to have for my project.
So I'm going to ask you a final kind of hotshot question to wrap this up. As a glass specialist, not necessarily more glazing is better advocate, but if you had to put an exact number on it, what is the perfect window to wall ratio?
Well, we've played around with some. I mean, we're not energy modelers, right, in our firm, but we've played around with like some models with a colleague to, and the energy codes are actually relatively good in terms of finding a sweet spot, right? So if you're looking at California, the 40% window to wall ratio that we're kind of getting told through the code as a starting point is actually a relatively good point. It's hard from there to optimize. What I see rather is if you go to what we typically build, which is more like in the 70 to 80% window to wall ratio, there's a lot of saving to be done if you then have to apply exterior shades or whatnot in order to improve those building performances. That 40% window to wall ratio is a relatively good starting point for a very energy efficient building. You can still further that, right, with shading overhangs and other aspects, but it's a very good starting point.
It also depends on the glazing placement. If you have street facing elevations, not necessarily thinking all 4 elevations are going to look the same.
Yeah.
So optimize where it matters.
True. Yeah.
Felix, thanks for coming on. That was fun.
Thank you.